The first thing is series network. So in series network, assume the three resistance that is connected in series. Like way, here is the three resistance. One is resistance. The resistance of this value of this resistance is R1, and the other resistance, this is R2, and the third resistance, that is R3, and so on. Maybe the so many resistance are connected in series. That is this is end-to-end connection. This is the first point. It is first point. This is the second point. There is an end-to-end connection. Means end-to-end connection means the end point of R1 is connected with the next point of R2, and the end point of R2 is connected to the starting point of R3. So this is the end-to-end connection. Here is the three resistors are connected in series, and these three resistors are connecting with a V voltage supply. It is connecting V voltage supply like this one. It is connecting V volt supply. So this is positive, negative V volt supply. Okay, and this V volt supply is flowing a current in this R1, R2, R3, which are connected in series. How can you decide these resistors are connected in series? Because the current which are flowing in this these resistors are starting from the positive terminal of this battery and end from the negative terminal of this battery. So the current which are flowing from the positive plate of the battery, that is I ampere, and this current is flowing like this I ampere, and here is the current flowing is I ampere. This is I ampere current. Okay, so this I ampere current is leaving current from this R1 is I ampere, and incoming current for this R2 is I ampere, and leaving current for this R2 is I ampere, and the again incoming current for this R3 is I ampere, and leaving current is I ampere. So this is I ampere because this current which are flowing in this overall resistance R1, R2, and R3, that is I ampere. So current through all the branches, current through all the elements which are connected in series, the resistance are connected in series, so the current flowing in all the resistance are same. Means R1 में flow करने वाली current, that is I ampere, R2 में flow करने वाली current, that is I ampere, R3 में flow करने वाली current, that is I ampere. So this I ampere are same in all the resistance. Okay, so the voltage across this R1 is voltage across this R1 is, that is V1. This is V1. Voltage across this R2 is V2, and voltage across this R3 is V3. Okay, so value of V1 and V2 and V1, V2, V1 is a voltage, V1 is equal to V is equal to IR. So this is I into R1. The current which are in the resistance of R1 is I ampere. Current V2 voltage is what? I into R2. This is I into R2. And V3 is, that is V3 is equal to I into R3. So these voltages, V1 is I into R1, V2 is I into R2, V3 is I into R3, but the overall voltage across R1, R2 and R3, that is V voltage. This is V voltage. Overall voltage is V voltage. So overall value of this V is equal to what? V is equal to V1 plus V2 plus V3. So the value of this V1 is I1 R1, I into R1 plus I into R2 plus I into R3 plus I into R3. So I is a common from here. This is R1, this is R2, this is R3, and this one is V. So V by I is what? V by I, that is the overall resistance. This is the V is the voltage, and the current which are flowing from this battery is I. So division of V by I, volt divided by ampere, that is known as ohm. This is in ohm. This is equal to what? This is equal to R1. plus R2 plus R3. So here you can say this R1, R2, R3 is equal to R equivalent. Okay, when the resistors are connected in series, so what are the conditions for the resistors which are connected in series? The first condition, the resistors are connected is into in connection, and the second connection, the current which are flowing into in connection. The second condition is the current which are flowing in R1, R2 and R3, all current are same. The current which are flowing in all the resistance which are same. So should be the same. Current through all the elements should be the same. These are the two conditions. First one is there should be the end-to-end connection. The second one is current through all the elements should be the same. Okay, now generalize this series circuit. How to generalize? If n resistance are connected in series, if n resistance are connected in series, are connected in series, likewise this is R1, this one is R2, this is R3, and so on, that is Rn. So this point is A and this point is B. So what is the overall resistance between RA to B? RA to B is known as R equivalent, because this is an in-to-in connection, and the current which are flowing in R1, that is I ampere. The same current which are flowing here I ampere. The same current which are flowing is I ampere. Here is the same current which are flowing as I ampere. So this R equivalent is equal to R1 plus R2 plus R3 and so on. That is Rn. Okay. This is and so on. So this is the series method. This is a series method. There is a two conditions should be satisfied. The first condition, the connection between the two resistors should be in type of connection, and the second one is the current which are flowing, both the resistance or all the resistance should be the same. Okay. So now move to the parallel circuit. In the parallel circuit, the resistance, the one point of resistance is connect a junction A. This is a one point and this is the other point. The resistance is R1 and next resistance is R2. This one is R2 and the next resistance is R3. This is R3 and next one is R4. Okay, so these are the four resistance. The one point of these resistance are connected to a junction A. Junction A means there is a one point. So these points are connected like way at a junction A, and the other points are connected like way. This is junction B. This is the junction B. Okay, this is junction B, and these all the resistance are connected in parallel, or are connected across a battery. This is V volt supply. Across the battery, this is V volt supply. So current which are flowing from here, that is I ampere. So this current is I ampere here, but this current is divided into a four parts. Because this current is divided into a four parts, this resistance having a current of I1, and this resistance having a current of I2, and this resistance having a current of I3, and this resistance having a current of I4. So from here, the current in the branch of R1, that is I1, current in the branch of R2, that is I2, current in the branch of R3, that is I3, current in the branch of R4, that is I4. So what is the overall current? So overall current, that is I ampere. This I ampere is equal to I1 plus I2 plus I3 plus I4. Okay. So what is the first condition? The condition first is resistance should appear across each other. So these resistance R1, R2, R3 and R4 are appear across each other because of this. The one point of resistance is connected with a junction of A, and other point of resistance is connected of junction B. And in same way, the one point of R2 is connected with the junction A. In same way, the other point of R2 is connected with the junction B. And in the R3 is also having a connected with the junction of A. R3, the next point is also connected with the junction of B. And R4, the one point of R4 is also connected with the junction of A, and R4, and the next point is also connected with the. So these all the resistance are connected across to each other, and the voltage across in all the resistance should be the same. That's how. Voltage across R1 is what? Voltage across R1 is what? I1 into R1. Voltage across I1 into R1. Voltage across R2 is I2 into R2. Voltage across R3 is I3 into R3. Voltage across R4 is I4 into R4. So this is equal to this. These are the voltages across R1, R2, R3 and R4. But all these resistance are connected across V volt supply. This is connected across A. This is connected across V volt supply. A point is connected to the positive plate. B point is also connected with the positive plate. So these are means the voltage across all the four resistance would be the same V. This is V is equal to, this is V equal, this is V equal. So what is the value of I1, I2 and I3? So I is equal to this one. What is the value of I1? I1 is equal to V by R1, and I2 is equal to V by R2, and I3 is equal to V by R3, and R4 is equal to V by R4. Okay, so I1 is equal to V by R1, and this is V by R2, this is V by R3, this is, so what is here? This is I is equal to V, there is a V is a common, this is V, 1 upon R1, 1 upon R2, plus 1 upon R3, plus 1 upon R4. So this is also represented as V by I. This is also written as V by I is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 plus 1 upon R4. Here this overall voltage is V, and the current which are outgoing, which are incoming from this battery, that is I ampere. So ratio of V by I is called the volt upon ampere, that is R. This R is overall resistance across A to B. It is written as 1 upon R equivalent, or in other words we can say this is RAB, written as RAB. This is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 plus 1 upon R4. So here the four resistors which are connected in parallel, these are measured by in this way. The condition is resistance should be appear across each other. Resistance should be appear across each other, एक दूसरे के across ही होने चाहिए. मतलब one point of resistance is connected a junction of A, the same point is connected to the other point of resistance, and the other point of resistance is connected with the same point. Okay, so voltage across each element is equal. So voltage across R1 and voltage across R2 and voltage across R3 and voltage across R4 should be the same. If their voltages across resistance are same, so these resistance are in parallel. So these are the four resistors are connected in parallel. If the two resistors are connected in parallel, so the formula is if the two resistors are connected in parallel, so this one is R1 and the next resistance is R2. These are in parallel and applied a voltage across V. So what is the overall current? The current is I is equal to I1 plus I2, and I is equal to, that is I is equal to I1 is equal to V by R1. I1 is a current in the branch of R1 and R2 is a current in the branch of R2. So this is I1 is equal to V by R1 and I2 is equal to V by R2. So this is 1 upon V by I is equal to 1 upon R1 plus 1 upon R2. Okay, so this is 1 upon R equivalent is equal to 1 upon R1 plus 1 upon R2. So this can be written as R equivalent, it is written as R1 R2 divided by R1 plus R2. So this is the formula for if the two resistors are connected in parallel. If n resistors are connected in parallel, so this one is the formula for 2. This is the formula for 2. Here is formula for 2 resistance. If the n resistors are connected in parallel, so if n resistance are connected in parallel, so n resistors are connected in parallel. So these are the resistance R1, R2, R3 and so on. This is Rn and this is V volt supply. It is V volt supply. So overall resistance across A to B is written as 1 upon RAB, or is equal to 1 upon R equivalent is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 plus 1 upon R4 and so on, 1 upon Rn. Okay, if the n resistors are connected in parallel, so we can use this formula. If the three resistors are connected in parallel, so the formula is equal to, if the three resistors are in parallel, so the formula is equal to 1 upon R equivalent is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So this can be written as R equivalent is equal to, this can be written as R1 R2 and R3 divided by R1 R2 plus R2 R3 plus R3 R1. So this is the formula for three resistors are connected in parallel. One important point in the parallel connection is resistance should appear across to each other. Resistance एक के अक्रॉस दूसरा रेजिस्टेंस होना चाहिए, दूसरे और उसके अक्रॉस पहला रेजिस्टेंस होना चाहिए, और वोल्टेज अक्रॉस जितने भी रेजिस्टेंस पैरेलल में कनेक्टेड हो तो उनके अक्रॉस जो वोल्टेज होगा दैट शुड बी द सेम वोल्टेज होना चाहिए. ओके, नाउ इन दिस लेक्चर we finish this lecture right now, and in next lecture we will discuss some numerical problem related to the series and parallel circuit. Okay, thank you all.